Hello everyone. In this video, we are going to discuss crystal field theory. It is a bit vast topic. This is part 1 of this topic. This video is on request placed through the comment box of my previous video on sp hybridization under class 11 chemistry, chapter chemical bonding and molecular structure. Okay, before we continue, I am Anandavali. I welcome you all to this new video from Guidance Education channel, and don't forget to subscribe, like, share and comment on videos presented in this channel. Thank you very much. I welcome you once again. Crystal field theory is a theory put forward to explain bonding in coordination compounds. The D block elements, which are called transition elements, form coordination complexes. You already know coordination compounds, which are normally called complexes, have one central metal atom belonging to the D block and a few groups or ions attached to it, which are called ligands. I use the letter M for the metal ion and L for the ligands attached to it, in order to explain the structure, that is, the shape of the molecules formed by the transition elements, the shape and properties of coordination complexes. The concept of overlap of hybridized orbitals is not sufficient. Those concepts were discussed in 11th standard. So, when you come to 12th standard, under coordination compounds, 3 new theories are introduced here. And crystal field theory is one among them. As already suggested, coordination complexes have complex structures. The central atom is the D block metal. For D block elements, the outermost orbital is the D orbital. That is, the D orbital takes part in bond formation, which has 5 orientations. These orientations have directional properties. It is this directional property which decides the shape and structure of the molecule. Therefore, in order to understand the metal ligand bonding in coordination complexes, it is very essential to understand the direction of these 5 orientations of the D subshell of the central metal atom. You are already familiar with the 3 coordinates x, y and z and its direction. We will first see that and then proceed to discuss the direction of the 5 orientations of the D subshell. The 3 coordinates are normally represented like this. This pattern of representation is familiar to us. This is the x-axis, this is the y-axis, and this is the z-axis, which are mutually perpendicular. But it is more customary to represent the x, y and z coordinates in a different way. This is the x-axis, this is the y-axis, and this is the z-axis. It is as if this structure is slightly rotated. Since it is this pattern of representation that is followed in the text, we will also follow this. It is not at all difficult. In whichever way it is represented, they are mutually perpendicular. There is no change in that. With this concept as our base, let us try to understand the 5 orientations of the D orbital. This is one orientation. The petal-like formations represent the possible electron density or the path of the electron. This orientation is called dx square minus y square. The orientation, that is the orientation of the electron density, is along the x-axis and along the y-axis. Hence the name dx square y square. This is the second orientation of the D orbital, which is called dz square. Here the orientation is along the z-axis. there is a central spherical portion also. That is the possibility of the electron density, the shape of the electron density. I hope you remember the donut shape and all. Now let us come to the third orientation. This is the third orientation and this is called DXY orientation. This is the x-axis as is shown here. This is the y-axis. The lobes are in between the axes. They are not along the axis. The orientation is in between these axes. When we come to the fourth orientation, this is the fourth orientation and it is called DXZ. This is the x-axis and this is the z-axis. See, the lobes of the possible electron cloud density is between the x-axis and z-axis. You have to imagine it in 3 dimensions. What I have shown here is 2 dimension. There should not be any doubt. In 3 dimension, it is between z and x axis. Now let us pass on to the fifth orientation of the d orbital and it is called dyz. This is the y-axis and this is the x-axis. The orientation of the lobes of the possible electron cloud density is between the y-axis and the z-axis. The most important thing that you have to remember here in order to understand crystal field theory is that the first 2 orientations, dx square minus y square and dz square, these 2 orientations, that is the electron cloud orientation, is along the axis and the remaining 3 dxy, dxz, dyz are in between the axis. They are not along the axis. The structure and the properties of the coordination compound that is formed will depend upon which of these orbitals take part in metal ligand bonding. We will continue this in the next video. I hope the video was of use. If you think it is useful, do like the video, share the video with your friends and also leave your feedbacks as comments. If you have not yet subscribed my channel, to subscribe it now. Thank you. Bye for the present.